Now the protected one, now if I try to access the protected method, what will happen? From the user's perspective, if I try to access this method, right? If I try to access this, if I try to build that, animal display info is inaccessible due to its protection level. So from the user's perspective, they cannot access this because it's protected. Protected is like private. It's similar to private, but the difference between the private and protected is the derived classes such as cat and dog, they can access that, but the user can't. So it's like a form of private, but the difference is from the private is the private can only be accessed by the animal, but the protected can be accessed. It's like a private, but it can be accessed by the derived classes. So for example, the cat and dog can access that. So in this example, it's display info. See how there's no issues. If I disable this one, the from the user's perspective, they can't access it, as I mentioned, because it's protected. But the cat can access it without any issue. See, there's no build errors, and this method is coming from animal. See how it says animal.displayInfo. Now, if I go to this definition, if I go to the definition, it goes to animal because it's defined in animal. So this cat class is deriving the animal's object and it's using it. So that is inheritance. That's the inheritance. So you're deriving this object, this method into here, and you can actually use it as if the cat it was part of cat, because the cat is derived from animal. So that is the advantage of inheritance, that you define it once, you define a piece of code in once. That, for example, these are also protected, the speed and the color. That means cat also has access to speed and color. See, these are actually defined in animals. See, they're defined in animals. So if I go to the definition, if I right click on it and go to definition, it actually goes to animal because that's where it's defined. If I go to the definition there, see, it goes to the animal again because it's defined there, but you can actually use it as if it was defined inside the cat, even though it's defined in the animal. So that is the benefit of inheritance. You inherit the data, the fields, and the method, so that you don't have to rewrite it. You can just derive it. So for example, the animal. So see these are equals, get hash code. It's deriving these methods from the object, .NET Framework root object, code object. So I don't have to rewrite them. The animal will all automatically get access to these methods for free. ToString, move is defined in animal, right? Ignore that one. Get type gives the type of the object. Get hash code, equals. These methods are actually defined in object, and you're inheriting those methods defined in object into animal. So that is the advantage of inheritance. So it is a very, very powerful concept. That's why it's used, right? So so what I'm doing here now, this is the cat class, right? This is the cat class. You can see in the animal, I gave a speed of 5. So speed is a field that defines the speed of the animal. So I'm saying the animal has a speed of 5 units, whatever it is, it doesn't really matter. But just for this example, it has a speed of 5, and this animal has a color white, right? But the cat, I'm saying I'm going to give the speed for the cat of value 6. And I'm not going to give it a color of white. I'm going to give it a gray color. All right? And that is the creation of the cat. Now, if I go to the dog, what happens here is it's very similar, right? So as I mentioned before, it can't access the private field or the private method, which we already went through. So again, the dog constructor, the constructor where the dog is initialized. So it says creating dog. It does the display info, initializes the values. Again, there's a display info just to see if there's any change, and then it's finished creating dog. Now, if I run this, so this again, these values, see, display info is defined in animal. So if I go to the definition, it goes to animal because you're deriving from the animal. Cat is also doing the same thing. See, it's deriving from the animal. If I go to the display info, it goes to the same one, display info, which is defined in animal. So dog, display info, if I go to the definition, it goes to animal, right? Because this is defined in animal. Same with speed, right? Speed is defined in animal, color is defined in animal. But because you're deriving those fields and those methods, this display info method and these fields, because they're protected, right? Because they're protected, you can access them. Because you're deriving them, these will become part of the dog. These ones defined in the animal will become part of the dog. Similarly with the cat, these will become part of the cat and will become part of it because you're deriving it from them, from the animal, right? So if I run this now, if I run this, you can see what's happening, right? So in the program, if you go back to the program, if I disable this one, so this is a way of commenting code. Commenting means you're disabling that line. So as soon as I put these two slashes there, that line becomes disabled, right? That means it won't run. So that's what commenting means, right? So this is also comment. There's other forms of comment. You can look into that on the C# reference. I won't go into the details, but you can look into that. So going back to the program now, what's happening here is it's creating a new animal, it's creating a new cat and a new dog. So if I run this, let's have a look at what happens, right? So first line is it creates a new animal, right? So this is the creation of the new animal. You can see if I go back to the animal, if I go to the constructor of the animal, you can see the first line, creating animal. That's one there. Then display info. Display info displays the speed and the color. 0 and empty because those values have not been initialized at this point of calling that method. Those values have not been initialized. Now I'm initializing the speed and the color. I'm giving value of 5, color of white. Now I'm calling display info, which displays the speed and the color. Now it's giving 5, which is assigned there, and the color white. So right. And then in the private method, I'm giving a value to the private field, which only the animal has access to, giving a value of 1, and I'm calling the private method, which displays, the private field, right? Private field, which we assigned a value of 1 to, and then you can see it's dumped that value there. So it's dumped, it's concatenated that string with that int value. Concatenation means you're putting them together. You're joining them. You're joining the string to this int field, and then you're dumping it there into the console, right? So that's what's happening. And then once the private method finishes work executing, then you're doing the console write line. It says finish creating animal, which is that one, right? So this is the instantiating of the animal. Now what happens after that? So what's happening? What's actually happening here? So you can see it's doing the same thing again. So it's creating, it's creating the animal again, right? It's creating the animal again. Then it's creating cat. So what is actually happening? So all I'm doing is, now if you go back to the code that's actually driving this program is driving everything, right? So this is the driver. This is the program that drives all the execution. Now you can see the first one is we created the animal, right? That animal was created there. Then we're creating cat. So when we're creating a cat, why is it creating an animal again? See how it's creating an animal again? It's doing the same thing again, the exact thing that happened there, it's doing it again. Then after the animal is created, then then it creates the cat, right? So what is actually happening? What is happening is, now we just went through the animal constructor, right? It does all those operations there. Now if you go to the cat constructor, if you go back to the console output, you can see that it is creating the animal again. So what is happening is, because the cat is derived from the animal, what it does is first, because it's derived, it creates the animal object again, right? So it constructs the animal again because it's derived. At this point, when it's executing this, because this cat object is based on the animal and it relies on the animal's data and the method, it has to actually instantiate the animal first because it's derived from that. So that's what you see happening here. See, it's initializing the animal first. Then once it's finished creating the animal, then it creates the cat. So, it says creating cat, which is that line, console creating cat. Then display does the display info. The display info goes back to the animal, right? So it's executing this method, which is part of the animal, right? And that will display 5 and the color white. Why is it displaying color 5 and speed 5 and the color white? Because in the animal's constructor, you can see it gave a speed of 5 to the speed and a color white to the color. That's why it's showing those values in there. Before it has 0 and empty, but you initialized it before in the constructor to 5 and white. So now in the cat will get those values. It'll get 5, the animal's value. These were actually initialized in the animal here, right? That's why you're seeing it there. Even though you're in the cat, you call them display info, right? It's showing the values that were initialized in the animal, 5 and white. But then what I'm doing is I'm giving speed a new value of 6, rather not 5, which is 6, which is a different value, and a color gray, which is different from white. And then I'm calling display info again, which again calls display info in the animal object, in the parent object. And then then it'll show the new value, see 6 and the gray, and it says finish creating cat, right? Same with the dog. If you look at the dog, same thing, it creates the animal, right? It says, before the dog is initialized, what happens is it creates the animal first, see? And it gives us value of 5 and color white because that's what that one does, see? Gives a speed of 5 and the color of white. And then it finishes creating animal. And then it starts creating dog because the dog is derived from animal, right? So you can see before, when the display info is called here, the values are initialized it uses the values that were initialized at the animal, in the animal object, right? That is why it's got the speed of 5 and a color of white. And then I'm changing the value of speed to 7, and I'm changing the color to black, right? And then I'm calling display info again, which goes to the animal, uses the display info in animal. It actually uses that method. And now it uses the new values that I gave, speed 7 and color black, right? And it created dog. So, so this is inheritance in action. This is inheritance and polymorphism in action. It also touches on encapsulation as well. So that is the the creation of the instantiation or the creation of the objects. So actually I'll just delete these lines. Let's stop executing it. Now let's go to the so access specifier. I think I'll just go over it again. So access specifier private, basically means that only that class can access it. In this case, only the animal can access this field, right? Protected means the deriving objects can access those. So cat can access speed, see? Speed and color, they're coming from the animal. They're coming from animal, they're defined in animal, right? But the cat can still access it and also change it, right? See how it says animal? Color is because it's defined in animal. Again, if in the dog, these are not defined. You can see it's not defined here. It's not defined anywhere. So where is it coming from? It's coming, again, display info. You can see that there's no method for it. Where is it coming from? It's coming from animal, right? So that's where it's coming from. So speed and color, these are all. So if I go to the animal, display info, you can see it's protected. Protected means that any deriving class can access it. Again, speed and color, they're protected. But if I try to access this one, it can't do it, right? So if I try to access from dog, if I try to access these two, if I try to build it, and if I go to the errors, see, it's giving error. Can't access it because it's private. This one, these ones, animal private method and animal private field, they're private to animal. That is encapsulation. You don't give access to private data and to methods to outside other classes and other users, right? So that is encapsulation in action. So let's have a look at these are the access specifiers, as I mentioned, private, only the animal, only the containing class, in this case animal, can access it. Protected means deriving classes such as cat and dog can access it. So this is the constructor, this is the private method, only animal can access that. Protected display info, cat and dog can access it, and they have done that. You can see that they have done that, they have used it, and they have used these protected fields as well. Now this one, public means anyone can access it. The user can access it, deriving classes can access it, anyone can access it. This is like, public is like, it's like a free for all, like, anyone can access it. It's like the least restrictive access level that is there. So anyone can access that. Now if I try to access this method, which is defined in animal move, there's no issues. I can access that. See, it's given access to it. Now if I try to build it, there's no issues, right? There's no issues. I can access that. Error list. But it's actually caching. That's why it says int counter. There's no counter. It's caching the previous for some reason. So but anyway, don't worry about it. If I restart Visual Studio, that will resolve itself. But you can see that the int counter has been removed, even though it's caching that value in here. The IntelliSense is caching it. So yeah, so this public access specifier. So these are access specifier, private, protected. The constructor is public, so you can actually create the object, right? Now if the constructor was private, then you will not be able to create the object. So if I change this to private, you will not be able to instantiate that object. Now if I were to build it, right, error list, see, is inaccessible. Can't access it. It can't create it. You can't even derive from that. See, because the protection, because in this one, in the program, you can't create the object because the constructor is private. You can't create. Constructor is what does the creation of the object. You can't create the object because you change it to private. And these ones will not be able to instantiate because it's deriving from the animal, which now has a private constructor, and these constructors are public, so there's a conflict there. That's why these are not building, right? So if I change this back to public, there won't be an issue. There won't be any issues. It'll be fine. See, it works now. There's no errors, right? So that's the constructor. Now this is a private method. This is a protector. That means the deriving class can access that. Now the public one, anyone can access that. Deriving classes, user, anyone can access it. Now you can see, now void, this one is a return type, right? Void means it doesn't return anything. I can actually return a value. I can return int. I can return int if I wanted to, right? But I mean, you can look into the details of that. But this is just a return type. Now you can see there's on this method, there's a special word called virtual, right? So virtual means that you want, or you're allowing the deriving objects to override this method and give their own implementation, right? So that's what the virtual, you're allowing it to be overridden. You're saying that the deriving classes such as cat and dog, they can have their own version of move. They don't have to use the animals one. They can have their own one. So the cat, let's just leave it as is. Look, a cat will use the animal's move method, right? It won't override it. But the dog, what the dog will do is it'll override it, right? So it'll override the move method and it'll give its own method, own move method, right? Rather than relying on the one from the animal. Now, now, if I so you can see that these animal, cat, and dog, they all have this move method because this method is inside animal, right? This method is inside animal, and these ones are deriving. Cat and dog are deriving or getting a copy of that method in their class because they're deriving. See, they're deriving from animal, right? So that's what it says. So if I mouse over it, it says it's from animal. See, it's saying it's from animal. Now if I run this, so you can see, as before, it finishes creating the, as before we went over this code before, this output before. Now you can see I have added these three new lines: animal move, cat move, and dog move, right? Now you can see something very interesting here. Now animal move, when you call this method, it calls the animal's move method. See this line here, animal moving at speed 5, which is the speed of the animal which we defined in the constructor, right? So that's correct. Now the next line is cat move. Even though it's cat move, it says animal moving at speed 6. So what is actually happening there? Now if you go to the cat, you can see that the speed is 6, which is correct. See, the speed is 6, which is correct, right? But it says animal moving at speed 6. Why is that? Because we have not overridden, in the cat, we have not overridden the move method. That's why it's like that. But if you look at the dog one, right, you can see it says dog move. Now if you go back to the program, you can see it says dog move. Calling that method, it says dog moving at speed 7. So what's happening there is, okay, you gave the speed 7, and but you have overridden the move. So you have given a new implementation to the move so that this move method is specific to the dog, right? So that is, you can override the function. You don't have to inherit and leave it as it is. You can inherit it and you can also change it so that it's more specific to that object. So you can see it's much better because the cat is saying animal moving at speed 6. Okay, it doesn't say cat, even though it's a cat, even though the cat is an animal, it's only saying animal moving at speed 6. But the dog is saying dog moving at speed 6, at speed 7, which is much better because it's specific, it's giving more specific information. So in the same way, you can give like more specific, more specialized implementation in the deriving objects, right? So this is like an overview of object orientation. So these